Hello, everyone, and thank you for joining us. My name is Gisela, and I will be the host for today's webinar. Before I pass it over to our speaker, let me cover a few housekeeping items. At the bottom of your screen, you will find multiple application engagement tools. You can adjust their size and position to optimize your computer screen. To expand your presentation area or maximize it to full screen, simply click to the arrows in the top right corner. If you have any audio or video issues, you can find answers to some common technical questions located in the Help widget at the bottom of your screen. Please note that the copy of today's slide deck and additional resources are available in the resources list. Please have a look and download everything that you may find useful. Also, this webinar will be recorded and sent via the email you registered with. Lastly, if you have any questions during the presentation, you can submit them through the Q&A widget. We are here to answer you live via the chat throughout the presentation, so don't hesitate to reach out. In case we run out of time or we didn't manage to answer your questions, we will make sure to follow up later by email. And now I would like to introduce our speaker. Today, we are joined by Carrie Brizek. She's the Director of Solutions for Aerospace and Defense at Jama Software, with focus on the specialized businesses and technical needs unique to this market. She helps lead the company in systems engineering and MBSE domain. She's over 25 years of experience leading systems engineering in the aerospace and defense industry with roles at the US government, Lockheed Martin, PTC, and Jama Software. She's a member of INCOZ and member of the Women in Aerospace organization. Outside of work, she enjoys playing jazz guitar and gardening around her farm. And with that, I will pass it over to Carrie.
Thanks, Gisela. A simple agenda for today's webinar. I'll begin with explaining just what concurrent engineering is, and then I'll give you a demonstration of Jama with some ideas for how to adopt those concurrent engineering practices, and then I'll just open up the floor for some Q&A. I'll start by telling you a little bit about my company, Jama Software. We're the leader in requirements management. Our purpose is to ensure that innovators succeed, with client success at the forefront of everything that we do. Through years of industry-specific experience and thousands of client engagements, we provide best practices and pre-built frameworks to help teams manage their product, system, and software requirements with live traceability through the development cycle. Our clients believe from faster cycle times and speed to market, increased process efficiency, visibility, control and quality, and streamlined reviews, compliance and risk management, all in a single source of truth. Our Jama Connect software and services help teams manage complex development in regulated industries such as medical devices and life sciences, automotive, semiconductor, space systems, airborne and defense, as well as non-regulated industries such as industrial manufacturing, finance, insurance, and software development. The reality at most companies is that the end-to-end systems development process is fragmented into domain-specific tools and spreadsheets that have no built-in collaboration. This leads to fragmented requirements traceability and requires significant manual effort through emails, meetings, and luck to try and prevent delays, defects, rework, and cost overruns. Most companies have come to accept this situation as an unchangeable reality, given the lack of a single platform to enable the entire process, nor a method to integrate spreadsheets and desktop tools. Concurrent engineering practices can help solve some of the lack of traceability and communication, but a collaborative requirements tool like Jama is what helps communicate the evidence and make sure what is being developed aligns to the mission, goals, and needs. Let's dig in. As defined by the European Space Agency, concurrent engineering is a systematic approach to integrated product development that emphasizes the response to customer expectations. It embodies team values of cooperation, trust, and sharing in such a manner that decision-making is by consensus, involving all perspectives in parallel from the beginning of the product lifecycle. Traditionally, engineers faced with the task of designing a new complex system or architecture work in sequence, one step at a time, passing the design from one subsystem specialist to the next without interaction with the rest of the team. That's the traditional, that's the old style. As seen in the figure on the left, this sort of sequential engineering begins with customer requirements and then progresses to design, implementation, verifications, and maintenance. The approach for sequential engineering results in large amounts of time devoted to product development. This drives higher cost and is less efficient, as products can't be made quickly. And this is a big deal in the space industry because, when we're in the early phases of mission analysis, you can't afford to have a really long, lengthy product development. Sequential really just doesn't make sense. It's just too expensive, and you need to come up with those variants right away. So concurrent engineering on the right is based on teamwork and focused on a common design model that evolves iteratively in real time as the different subsystem experts provide their contributions. Designers and customers agree on requirements and take decisions in real time to allow the best design for the right cost within the programmatic constraints. So concurrent engineering, it allows for all stages of product development to occur essentially at the same time, sort of as seen in the sequential engineering versus, concurrent, the figure in the middle of the screen that you see. Initial planning really is the only requirement before the process can occur, including, planning, design, implementation, testing, and evaluation. The concurrent design and manufacturing approach allows for shortening that product development time, gives you higher efficiency in developing and producing the parts earlier, and it lowers those production costs. The European Space Agency commonly, produces a costed, risk-assessed, conceptual space mission or, system design complete with various options, including the scheduling, testing, and operations, really in only just a few weeks. And they've been doing it a really long time. We think that, concurrent engineering and design manufacturing, it emphasizes parallel types of tasks. So you have, sort of like an integrated product development approach, some people might call it. It really has it so where the functions of the design, engineering, manufacturing are working in parallel at the same time, highly collaborative to bring that new product to market. So who uses something like concurrent engineering? There's a lot of people, right? Base agencies like the European Space Agency and NASA, even automotive companies like Toyota and Harley-Davidson, contract manufacturing companies, even large energy and oil companies. There's a lot of organizations out there that are doing it and doing it very successfully. Concurrent engineering isn't something new either. Like I said, the European Space Agency really has a rich history of employing it in almost all of its projects. In the early years, in the 70s and 80s, when it was just formative, the European Space Agency primarily focused on collaborative projects among its member states. They didn't really call it concurrent engineering. They might not have had that term for it back then, but it was starting to get formalized, and especially well known on the Ariane rocket program. In the 1990s, this is when ESA began to formalize the actual methodology for concurrent engineering within its own project frameworks. They established those dedicated teams, and they aim to integrate the engineering disciplines early in that design phase to mitigate the risks and optimize for mission success. They applied the principles across, a variety of projects, including satellite development, space probes, international collaborations like the Hubble Space Telescope, the servicing missions, right?